Good afternoon, students. Welcome to Analytics Powered Virtual Interactive Classrooms. So, how are you all, students? Are all of you all right? Having fun? So, very good. So, I hope all of you are doing well and study properly. Okay. So, students, in our yesterday's class, in our previous class, we have seen some basic properties of the parallel lines and the perpendicular lines. Okay. Remember? So, we are going forward from that part only. Okay. So, today, you have to observe the content carefully. Okay, so I am starting, okay, without any wasting any time. So up to this we have done. Okay, so we have seen that there are some notations are there, that in mathematics we use a row mark, okay, or arrow mark to show the set of lines is parallel like this. So these two lines are parallel, as well as, so if there is more than one set of parallel lines, then the second set is shown with the two arrow marks like this. The first set is like this one, and the second set of parallel lines is this one. Okay, and similarly in the last one is perpendicular lines. Perpendicular lines means they lie in this way. Okay, so perpendicular lines are named or marked with a square angle between them. That square angle measures what? So what is the measurement of that square angle? Very good. So that square angle makes 90 degree. Okay, the 1/4 of a complete angle, that is 360 degree. Okay, remember? So up to this we have done. So we are moving forward. Okay, fine. So look, now there are some problems. Now what is the problem, sir? The problem is in the figure given below, mark the parallel lines. So you have given a figure. Okay, so in that figure you have to mark the parallel lines using the notation. Okay, mark the angle between the perpendicular lines with a square symbol. Okay, now let's move forward. The question number A says, how did you spot the perpendicular lines? Okay, or how did you spot means how did you say that that kind of lines are called as perpendicular lines like that? Okay, and the second one is, how did you spot the parallel lines? Okay, how did you spot the parallel lines? Fine. So now look, so that's our figure. Okay, any idea about the figure? Okay, any idea that what kind of lines are called as parallel lines here, or which kind of or what kind of lines are called as perpendicular lines here? Any idea? Suppose I am a basic example. Okay, suppose we are taking that line. Look at the screen. We are taking that line, yellow line. So if I compare, so in all of the above, so if I take again this line, so are these lines parallel? Are these lines parallel? Means, is there any possibility? Okay, is there any possibility that this kind of or these two lines meet or intersect with each other? Is there any possibility, students? I hope your answer will be no. Okay, why? Suppose we are extending this one like this. Okay, so it will be a straight line. So similarly we are expanding this, and this is again a straight line. So now by an assumption, okay, we can say that sir, these two lines never meet with each other or never intersect with each other. Clear? So in that case we have to say, or we must say, that these two lines are called as parallel lines. Remember? Fine. So like this we will find the solution. Now coming to the solution. So this is your exact figure. So now look that. So this one and this one means this line and along with this line. These two lines are what? Parallel lines, because we know that parallel lines are have been showed by the arrow mark. Okay. So this line along with this line. So these two shows the double arrow mark. So these two lines are parallel. Fine. So look at the figure carefully. So now that one is a box. So box or square angle. So square angle means what? Square angle means a 90 degree. Okay, square angle measures 90 degree. So this is a line, along with this is a line. So in that case we can say that these two lines make what? Make a right angle. So for that reason, these two lines are called as perpendicular lines. Got it? These two lines are called as perpendicular lines because we know that whenever two meet at or intersect at 90 degree, so that kind of lines can be called as what? Perpendicular lines, isn't it? So like this. So we can say that this line and this line, these two lines are called as perpendicular lines. Nice. This one and this one. Similarly for this one and this one. Okay. So these two lines are parallel. Okay. The next one is, as I mentioned earlier, or as I said earlier, that this one and this one. So double arrow mark. We have seen here the double arrow mark. So these two also represents that these kind of lines are parallel lines. Okay. Now this is a what? This is a right angle, 90 degree. So 90 degree refers that its adjacent sides are what? Perpendicular to each other, like this. So that and that. So these two lines are perpendicular lines. Okay, like this. And similarly for the others. So you have checked by yourselves. Okay, so like this. So we have done. Fine. So this is a part. So how did you spot the perpendicular lines and how did you spot the parallel lines? We all done it. Okay, so we have done it. Okay, next. So now I have to give the proper answer. Now I have to give the proper answer that you have to spot the perpendicular lines first. Clear? So perpendicular lines meet at a 90 degree angle or right angle. Okay, right angle measures 90 degree. Clear? So perpendicular lines meet at 90 degree or right angle. Okay, all of you know. So now how did you? Now what is the reason behind it? So the reason is that parallel lines are a pair of lines that lie on the same plane, and do not meet however far we extend them on both the ends. Okay, and do not meet means they do not intersect with each other, like this. They do not. Okay, however you extend them against with its what? Both of the ends. Okay, so do not meet however far we extend from both of the ends or them from both of the ends. Okay, so these two lines never meet with each other or never intersect with each other. Okay, so these two lines are called as parallel lines. So these two are the main reason behind it. So like this. Now there is a question time for you students. So look, what's the question? That what is the angle between the two parallel lines? Okay, it's a nice question. Okay, what is the angle between two parallel lines? Two parallel lines. So what is the angle between them? Option number A 0 degree, option number B 90 degree, option C 180 degree, and option number D is 360 degree. I am giving you a time of 1 minute. Okay, answer it properly students. What is the angle between the perpendicular lines? What will be it? What will be the correct answer? Okay, go ahead. You have to find the angle. Okay students, 15 seconds more, answer it properly. I need the accuracy. Okay, and the time's up. Okay, now we are explaining. Okay, so what is the angle between the two parallel lines? First give me the answer that what is the angle between a perpendicular lines. Okay, what is the angle between two perpendicular lines? What will be the answer? So the answer will be what? 90 degrees, sir, or a right angle. Yes, 90 degree. Now why it makes 90 degree? Because both of the Because both of the lines intersect with each other. Both of the lines intersect with each other. I am giving you a hint again. So suppose this is a case, okay. That case refers that in a what in any of the there is a possibility that these two lines met like this one, okay. So they will meet at one point, clear. So whenever, now look, now whenever the two lines meet with each other or intersects each other, then there is a intersecting point, right? There will be an intersecting point, isn't it? There will be an intersecting point. Now when we got an intersecting point, so from that intersecting point, so there will be a rise of some angles. Some angles will be formed in that case. That is the first angle, okay. That is the second angle. If you look carefully, that is the third angle, and that is our fourth angle. So we have seen that whenever we got one intersecting point, so in that case, when two lines intersect with each other or meet each other, so in that case, total how many numbers of angles will be formed? Very good. 1, 2, 3 and 4. Okay. But in that case, when the two lines are parallel, is there any intersecting point, or is there any possibility that we can get an intersecting point? Got my question? My question is there any intersecting point? That is in the sense of definite sense. Okay, is there any intersecting point between the parallel lines? And the indefinite question is means a possibility, or will be a probability. Okay, is there any possibility that these two lines intersect with each other and we will get an intersecting point? Is there any possibility? So the answer will be no. We know that the answer will be no, right? The answer will be no. And in the definite sense, they do not intersect with each other. Now if they do not intersect with each other, so we didn't get any, or we doesn't get any intersecting point, or we are unable to get an intersecting point, right? So if we are unable to get an intersecting point, then how can we say that some angle will be formed? Got my point? If there will be no intersecting point, then how can you claim that we will get some angles, right? So in that case, you can say that, sir, no such angles will be formed. Okay, no such angle will be formed. So if no angle will be formed, so what will be the measurement of that angle? What will be the measurement of that angle? 0 degree, right? So our answer will be 0 degree. No angles will be formed. So no angle. The angle is what? The angle doesn't exist. So in that case, we can say that 0 degree. Now 0 degree is what? Suppose we got a point, okay. Suppose we got a line, and we got, suppose here is a 30 degree. So 30 degree is like that. Whenever, suppose I am taking this line, okay. Now whenever 0 degree is like this, suppose this one, this is our first line, and the second line lies over it. So in that case, 0 degree will be made, okay, will be made, and in the second case, this will be formed, that both the lines are parallel. Or you can say when both the lines lied with each other, okay, lied with each other, then in that case 0 degree will be formed. So we will say that option number A will be the correct answer. Discussion clear? Very good. Now next, okay, now look at the screen. Okay, so there will be an activity. So fine, look, he folds the paper like this way, okay. He folds the paper, nice. Okay, so this is the fold of the paper, okay. If you see carefully like this, so we are making the lines using the ruler, okay, ruler, and using a pencil. Fine. So we are doing it. So AB is a line, AB is a line, and as well as CD is another line. Got it? Now what happens? Look, okay, now he is doing another fold. Okay, so after we get it, so we have to join these two lines. Okay, so join the lines. So we will name it as M and N. So there will be another straight line or line segment, you can say, so that is MN. Okay, fine. Now the intersecting point, so there will be some intersecting points. Look, so this is the intersecting point of that. P is the, I am writing here, intersecting, look, intersecting point of line MN and AB, correct? Correct. And that one is Q, which represents the, it is the intersecting point of line MN and CD. Clear up to this? The P is the intersecting point of line MN and AB. Okay, and Q is the intersecting point of line MN and CD. Clear? Very good. So like this one and this one, okay, along with MN. So M is a transversal. Okay, so we can say that yes, like this. Yes, MN is a transversal. MN is called as transversal. So whenever a line exists that intersects one line, two line, or more than two lines, so that kind of line is called as transversal. That is our definition. Okay, so MN is called as a transversal here. Okay, now in the next slide, yes, so we have seen that there is a scenario of a city. Okay, so this line is made. So now can you explain me that what kind of line it is? So if you carefully see, so we are taking, look, the roads here. So roads is like this one and this one. So these two are parallel lines along with this one and this one. Okay, so we are taking that lines, using that lines. Okay, look, yes, so this is the lines and this is the transversal. This is the transversal. Got it? This is the transversal. So this is our overall figure. This is our overall figure. We are taking a random figure. Correct? Nice. Now I am naming all of them. That line is XY, that line is AB, and that line is CD. Now here both the ends are denoting with arrow marks. So it means that it extends to infinity. The line will extend to infinity. Okay, fine. Okay, so CD and another one is XY. Got it? Nice. Okay, so that is the AB line, that is the CD line, and that is the XY line. So here there will be one second. Okay, so look, so there will be two intersecting points, correct? So there will be two intersecting points. Okay. What is our definition? So the definition is that whenever a line intersects two or more than two lines, whenever a line intersects two or more than two lines, so that exact line will be called as a transversal. Correct? So in that case, which one will be the transversal? Is it AB, or is it CD, or is it XY? Which one? So answer will be that, sir, XY will be the transversal here. That is our answer. That is XY will be the transversal. Correct? Nice. Very good. I am going forward. Okay. So now look at the screen here. So it's an office. Generally, it's a scenario of an office. So using that one, so Now we are taking these lines, this one, and this one. So these lines are parallel. We know that these lines are parallel and they will never intersect with each other whenever we extend it to the infinity. Okay, they will never intersect. Fine. And this is another. Okay, I am taking another. Okay, so this is our another line. Now, which line intersects two or more than two lines? Observe carefully. Observe carefully. Which line intersects more than two lines, sir? If I take this one, so as I am seeing here that it intersects only this one. Okay, only this one is there. If we take this one, only the intersecting point will be this, and if we take this line, so only the intersecting point will be this. But when will we take this one? So this one intersects this one, and this one. Means three intersecting point lies on the straight line also. Three intersecting points lie on the straight line also. So in that case, we can say that this line, that red colored line, will be the transversal here. So look, so the line that intersects two or more lines, so that's our definition, correct? So that's our definition as I mentioned earlier, okay? So the line that intersects two or more lines at a distinct point. Distinct point means what? So distinct will be a new word will to you. Okay, I am giving you the distinct. Is it visible? Okay. 1 second. Yes. Distinct. The word distinct means different points. That's the simplest English. Distinct means different. Okay, distinct points means different, or here we are saying the distinct points means different points. Okay, suppose what? This is one intersecting point, this is one intersecting point, and this is one intersecting point. So we all know that these three are different points. Yes, or you can say that, or have you say that these two lines are same? No, the answer will be no. Okay, basic knowledge. So this one, and this one. So these three are distinct points or different points like this. Okay, so distinct points on a same plane is called as transversal. So that's the basic definition of a transversal. That is when a line intersects two or more lines at a distinct points or at some distinct points on the same plane. So that kind of line will be called as transversal. So that's our basic definition. Okay, very good. Now next. Now it's a what? It's a square sheet. Yes, it's a square sheet. Okay, now I'm doing what? Yes, I am coloring that part. Okay, so that is our interior and that is our exterior. Interior means what? The part of inside, or you can say that inside part, and exterior means what? The outside part. I hope all of you will understand. Okay, so exterior means our outside part and interior means our inside part. Okay, so I am taking these two lines using the fold of the paper. Okay, now that is our another line. Now according to the definition of the transversal, so you tell me students that which of the following lines will be the transversal. Which of the following lines will be the transversal? So according to the definition of the transversal, can you say or can you answer the question? Very good. So those who are saying that, sir, this will be our transversal, exactly correct. So in that case, there will be two intersecting points on the line itself. Okay. So in that case, we are naming the lines. That is, first one is AB, that is CD, and that is PQ. So in that case, and the intersecting points is K and L. The intersecting points is K and L. So AB line, that is the CD line, and that is our PQ line. So in that case, you can say that, sir, PQ will be the transversal. Okay. Fine. So in the transversal, I have mentioned one thing. Okay, if you remember that if we get, I am writing here. So that's another part topic. Okay, if we, okay, one second. That's a note. If we get an intersecting point, if we get an intersecting point, then a total of 4 angles will be formed. I hope that English is clear to all of you. Formed. Okay. It's up to this. So what am I saying? I am saying that if we get an intersecting point, if I get an intersecting point, okay, when two lines intersect to each other, then a total of 4 angles will be formed. Now what is the 4 angle? Suppose this one. This is first line and this is our second line. So what will be the intersecting point, sir? That will be the intersecting point, correct? So how many angles will be there? Look. So this one is first angle. Okay, isn't it? This one is the first angle. This one is the second angle. Right? Okay. Only the magic of observation. Okay. This one is the third angle. Right? So this one is the third angle. And similarly, this one is our fourth angle. Look. So how many a total of how many angles will be there? 4. 4. Definitely means exact 4 angles will be there. Okay, when we get an intersecting point. So that is a note. Okay, the magic of observation, students. Okay, if we get an intersecting point, then a total of 4 angles will be formed. Fine. So now here look. So okay, I am showing the animation. So here at the intersecting point of, okay, at the intersecting point of PQ line and AB line, at the intersecting point of PQ line and AB line, a total of 1, 2, 3 and 4. 1, 2, 3 and 4 angles will be formed. Now I am writing here, and similarly for that case. Okay, so 1, 2, 3 and 4. So you see here that 1, 2, 3, 4 angles will be there. Okay, and that is the intersecting point of the line PQ and CD. That is the intersecting point of the line PQ and ACD. Correct? Very good. So angles formed by a transversal. Okay, so that's our point here. So total 1, 2, 3, 4, 5, 6, 7, 8. So total 8 angles will be there. Okay, because we got 2 intersecting points. Okay, if one intersecting point is there, one intersecting point. Okay, if we got one intersecting point, the total number of angles formed will be 4. If 2 intersecting points will be there, okay, I am generally writing, suppose one intersecting point, IP, okay, one intersecting point, so total angles will be formed by 4. If we get 2 intersecting points, we get 8, double. If we get 3 intersecting points, so our will be 12. Okay, the multiples of 4 or the table of 4, 4, 8, 12, 16 like this. So here we got the 2 intersecting points, so our total angles will be 8. 1, 2, 3, 4, 5, 6, 7, 8. Clear? Okay. Now, so okay, one second. So what is saying here? Okay, so angle 3, angle 4, so this one, angle 3, angle 4, angle 5 and angle 6. So these 3 lies in between the coplanar lines because AB and CD. So these are lines inside. Okay, these are lines inside. Okay, these lines are lying inside. Okay, inside the lines, coplanar lines, AB and CD. So that's why these are called interior angles. So similarly, what will be the exterior angles like? So which one? Yes. So 1, 2, 7 and 8. Look. So we are taking these lines, these lines. So that part is our outer part. Correct? So in that case, that one, that one, that one and that one. So these four lines are called as, these four lines will be called as what? Exterior angles. Correct? So we are saying that angle 1, 2, 7 and 8 lie outside of the coplanar lines AB and CD. So that's why these lines are called as exterior angles. Sorry, these angles are called as exterior angles. Okay. So up to this, I am ending my class. Okay. So is there any doubt? Okay. I hope all of you will understand the topic, today's topic. Okay, we have seen the what, the basic properties of some parallel lines and perpendicular lines. Then we have done what? Then we have seen the angles, the transversal. Okay, and the transversal is the definition of the transversal we have learned. And then we have seen the angles formed by a transversal. Okay, whenever they intersect two or more than two lines. Okay, then we have learned the interior angles and as well as the exterior angles. Interior angles and exterior angles. Interior angles means when the two coplanar lines are there, the inside angles will be called as interior angles and the outside angles will be called as exterior angles. Okay, so I hope all of you enjoyed today's session. So we'll see you in the next class. Okay, so thank you for joining with us. Okay, so take care students and enjoy your time. See you in the next class. Bye.